Hello everyone, welcome to my YouTube channel. This is the second video of my lecture. In this video, we would like to talk about CFD versus FEA and MBD and understand what, why and when to use each. So why this comparison matters? Many beginner hears CFD, FEA, MBD and get confused. The tools look similar but they solve very different problems. Choosing a wrong method can waste lots of time and the money. So in one line definition I would say if CFD deals with mostly with fruits moving, whereas FEA deals with solid deforming and MBD deals with parts moving together. As you can see in the picture, for the CFD there is a car body on which the robots are painting. So here the paint is basically the fluid, and in a CFD software you will get to know the behavior about how it is sticking to the surface, what kind of thickness it is going to generate and so on. In the second picture, this is a typical example of a FEA simulation where a force is applied on the cantilever beam, and you can see that when you increase the force, the stress is going more where you have applied the force, and here you can see at which point, at what force, how much the bend is gonna be. In MBD it's basically deals with multiple moving parts. So as you can see picture in the right side, it's a car body, let's say the mechanism, the and there you see lots of parts are stick together, and when they are moving they have frictions and there's contact forces are there. So in MBD you deal with checking these forces. Now coming about the CFD, what kind of solution CFD provides? So the CFD provides how does the airflow, how water moves, and how the heat transfer happens. So the output, if you see as for a CFD software, usually it is velocity, pressure and the temperature. In real world example, if you see, let's say if you want to simulate airflow around the car body, or you want to simulate about the internal temperature when the car is running, and when you want to see the heat and ventilation inside a building or inside a car body, or also if you have a circuit board and then it's heating, generating the heat, and you want to simulate it and see how the cooling will happen for the electronics. So these are the some real world examples. If we talk about FEA, finite element analysis, what does it is? It basically answers the questions like will this part break, how much would it bend, and where is the stress. And here you will have a typical output as a stress, strain and deformation. In real world example, if you see the crash analysis test, so as you can see in the picture in the left side, that there is a truck, the mini truck you can say, and now the analysis is done like when there is a crash happens, where and how the part is gonna be deformed. Second one, if you see the right side picture, it checks with the strength analysis. So for example, if there is a rod and it is let's say there is a uh, part here which is pushing to the rod, then you can see the here the force is more. So this way you can check the structural strength of uh, a part. Then next is about MBD. what it is. So it basically deals with the like it gives answer about how does the part move together, what are the forces at the joints, is the motion is smooth or jerky. So mostly it focuses on motion, joints and constraints. Some real world example is in a moving car there are lots of part like at the wheels. So in the wheel if you see it's rotating, so you wanted to check that whether the rotation is smooth or it is having a lots of pressure. So it's, let's say if there is some part which is generating more force, the problem will be, it will be creating problem in the wheel movement, and that part will be decaying faster. Similarly, if you see in the robotics, in the robot, it basically checks for the pressure building on the arms. So when you are dealing with the robotics, it is very important that when the part is working together, they need to be working properly, and they have to deal the let's say load and the pressure in a way that it's not creating a structural damage. Similarly, in a gearbox, there is, let's say here the shaft is there, so the gearbox is rotating. So here you analyze that how much force is going, like it's taking in the like in XY direction. So this way you can analyze it, how much time the part will last. So this is the preliminary analysis which can help a lot in deciding the design. So if you talk about a simple analogy, so think of a car. In a car, let's say if you apply CFD, so that is basically air flowing around the car. FEA is car body strength and crash safety, and MBD is basically suspensions and the wheel movement. So for one product, you have a multiple simulations. And here is a small comparison table. In the comparison table, as I mentioned here, if your studies are, let's say CFD, then it is a fluid study. FEA, it's a solid study. MBD is motion studies. What kind of meshes you use basically is, in CFD you use volume mesh, or you call as also is like surface mesh. In FEA you have a solid mesh. Then in MBD you have rigid bodies. The outputs are, the main output here in the CFD is flow, heat. In FEA you have a stress, strain, and in MBD you have a forces and motion. How about the time base? So in CFD properties are often time based. In FEA it's sometime like a time based. In MBD it is always about time based. How, based on like with the time, how much the decay is gonna be and how much the part is gonna be lasting. This is what the analysis provides it. So does they work together? Yes. How they work is, let's say giving example is, in MBD it starts giving a load, and in FEA it checks the strength, and CFD it checks for the same part, the cooling and the airflow. So the question is which one you should learn first. So if you are interested in aerodynamics or HVAC, you should learn CFD. If you are interested in structures and the mechanicals of it, then you should study FEA. And if you are interested in vehicles and the robotics, you wanted to uh, design a vehicle, in that case you study MBD. Start with one, not all of three. You can learn gradually all the tool, but in order to be an expertise, choosing one is very important. So there are some common misconceptions about this. So can CFD replace FEA? No, because there is they deal with the different types of problems. Can there be one solver which does everything? No, because every solver has its own physics and own way of handling the complexity. If you try to do everything in one, it's nearly unmanageable that you are able to do one tool and then this tool works for all the problems. So you have more physics inside, so if you are dealing with only one tool, you can add more physics and then you will be having a better result. This physics supposed to be, as I said, the correctness is more important than the complex. So people use correct physics there rather than adding lots of complexities. So that's all for today's lecture. In the next lecture, we go dive into more in CAE software. We'll see how the mesh is taken inside in the software and then it does the simulation and produces the result. Thank you. Thank you for joining. See you in the next video.